So with that, we will go ahead and get into some backend web attacks. So I don't know how many of y'all made it to the front end web attacks, but this is kind of the second part of that series. Last we were talking about front end attacks. We were talking about attacks you can do on the client side. And this week we're going to go over and start looking at what happens in between the time you type in Google and when you get the web page in response. We're going to talk about all that stuff that happens on the server. And this includes a lot of different stuff that we're not going to be able to cover. So what we're going to do, instead of trying to go cover everything, is we're going to cover like two different things, and then we're going to try to abstract them into some themes. And I think that'll be really helpful because, like, literally, the hard thing about these backend attacks is that a lot of them are dependent on the software that the backend is running. So if your backend is running PHP, you're going to get a lot different attacks than if your backend is running something like Node.js or anything, or like Flask in Python. But that's where all this stuff is going to be happening. It's all this stuff that happens on the backend, and that's going to be really important. It's really important to understand that this is all this code is getting executed on the server. And one of the side effects of us attacking the server instead of the client now, like we were talking about cross-site scripting, that attacks the client because the person who is actually using the website is the person who gets exploited with cross-site scripting. The JavaScript gets executed and you can steal their password. But here on the back end, it's going to be a lot more, the stakes are going to be so much higher because when you infect a client, you're able to infect one user, but when you're infecting the like water source itself, you're able to like poison the well, and you can go attack everyone who's using this website. And like when you start talking about post exploitation, you can start pivoting off the back end and start doing this recursive thing where because of the firewall. So when you're getting to the back end, you found a hole in the firewall, and you can start recursively doing this, attacking again and again and again, and you can get more access, and eventually you can just take over the whole corporate network and delete all the logs, delete all the backups, and just nuke the whole thing. So it's pretty high stakes here. We just talked about this. So yeah, the vulnerabilities are heavily based on the backend technology. That's something that I want to like emphasize here. And the injection is going to be the main idea. So the thing that is going to happen here, basically like at a very high level, is that somehow this backend is going to be accepting some kind of user input. And our goal is going to be to exploit the user input here. So we're going to give the server something that it doesn't expect. And then the code, whether it's because a programmer messed up or it's because there's just like a fundamental flaw in the design of a software, then somehow we're going to be able to go exploit this. So to start off with this, like a really simple example is HTML and PHP. Can I get just like by a show of either ones if you've heard it, ones if you know it, zero if you don't, on people who are familiar with PHP? Like maybe you don't like, you're not like an expert in it, but like just kind of, okay, so most people aren't. So I'll spend a good amount of time on this because this is really important, and it's a little bit, it's interesting. This is pretty interesting thing here because HTML we talked about is executed on the client side by the web browser. But the PHP is executed by the server. And it gets a little bit tricky here because you can actually you can interpolate the PHP inside the HTML. So how does that work? The way that works is that you have some PHP code that you write in a file. Okay, so so there's some PHP that you write in a file. You might call it like index.php. And so you have this PHP code here, which you use the PHP tag right here to go do. And this all gets executed as server code. So when the client gets sent a response from this, they do not see any of this stuff in purple here. They will just see welcome Leo is the name up here, and it'll get stuck into the string here. If instead of seeing echo date Y, they're going to just see the actual date. They'll see the year 2020. So all the stuff in here is executed and interpreted by the server. And then once the server handles all this PHP stuff, it might even have an error and you just don't get a response at all. Or you get like half the page and then there's an error. It gets sent back as HTML. There's no PHP getting executed on the client side. Does that make sense to everyone? Does it not make sense to anyone? We can talk about some more, or if there are any questions about it. So we'll come back to this in a second because this has a lot of interesting side effects. We actually talked about some of the side effects when we were talking about some front-end attacks. So what are the parts of a backend? Just to frame this a little bit more, let me grab my computer charger. To frame this a little bit more, what are the parts of a backend? So we are talking about the client here. The client goes in and basically the client is always using the front end. But when you go and you like click submit on a form or you load a web page, there's a whole lot going on that you don't see. And one thing that makes it a little bit more hard when considering the security here is that we don't necessarily know what is going on the back end. On the front end, we can go like view source, we can go inspect element, we can do all this stuff. But with the back end, there's a lot of guesswork and reverse engineering that we have to go use. So you could do a whole lecture on like different ways to go try to figure out like what service the back end is using. There's websites like builtwith.com that'll do this for you. You can go sometimes look at the HTTP headers and see this kind of stuff. You can use Nmap, a lot of different tools for it. But usually what will happen is there's multiple layers on this graph here for what the backend is doing. There's the thing that you're going to directly interact with, which is what we call the application engine. That could be PHP, it could be Node, and usually there's an exposed input that the client can access. So they can go maybe post to a login form, they can go get a web page, anything like that. Sometimes it'll be on another domain. These two things happen on port 80 and 443 most of the time. 80 is HTTP, which is bad. You should never use HTTP. And there's 443, which is HTTPS. So right here when I'm on like docs.google.com, the HTTPS has an implied 443 at the end of it. For Minecraft, it's 25565. You don't have to go put the 25565 because it's implied if you don't put anything else. Most services that you will use have a default port. So, but then the other part here is a little bit trickier because it's a little less straightforward. So the application engine is also going to be talking to a database most of the time, because you can't just you can't keep all your stuff in memory, because what if the server crashes? You have to have a database that has backups and other like complex information about it. So the database is going to be on its own port, and usually the database, if they're smart, is going to be behind a firewall. So you will not be able to go from the front end all the way to the database. You'll have to go pivot off of the application engine. But we can pivot off the application engine pretty easily. And that's what we're going to talk about. Okay. I probably should have started with that one. So we'll talk a little bit about... Actually, I don't think we need to talk about that. So we're going to skip that. So the things that are happening here is whenever you make a request, you can send some variables along with it. So on this one right here, for example, we make a request to 127001, which just means like our computer. This is reserved for a loopback to your computer. We're calling the index.php page here, and then we're doing a question mark, which is what divides the URL with the parameters that go into that URL. So then we can just say like name equals test, key equals value is the abstraction there, and then we can do a second variable, age equals 15. So then in the PHP, remember that this is this right here is part of what makes up the nature of our request. So we are able to then access that on the server side right in the middle of the transit here. And we can go say like this variable called name is equal to get name, age is equal to get age. And then we can go like, I mean, if we really want to, we can just print out name here. So then this web page is going to come back with like hello test in this example right here. Are there any questions on that? Because we're going to get a little bit more. So usually this is not literally what's going on. Like it's going to be a lot more sophisticated when you're looking at an actual web application. So right here is the point where if you have any questions, I would ask them because it's going to get a little hairier from here. If you have one, you can like say it out loud, or you're welcome to put it in the chat. So let's talk about a little bit more like realistic. Let's talk a little bit more realistic backend logic. First, I'll take that question. The question was, most of the time they use post, not get, though, right? Yes, that's true. And so we'll use post here. You really don't have to know like the difference to do this. I can show an example. Actually, I will show an example actually in a couple minutes of like get versus post being used. But post basically means the variable still gets sent, but they don't get sent in like the question mark test equals like or key equals value format. They get sent in the actual body of the request. So they're a little bit harder to go forge is one of the reasons that you would use it. And also if you were logging into something, you would never want to go say like username equals or like I mean just to get right to the point here, password equals this is a bad password or something. Because then anybody looking at your computer can see what your password is. So that's why you want to use post at a high level. So what happens a lot of the time in with backend logic is you're accessing you're taking in user input and you're doing something with that user input that involves getting additional information from a database. So maybe that user input is a username, maybe it's a search query, maybe it's a username and password to go log in, which is what's happening right here. It can be a lot of different things. There's an infinite number of things that it could be. But in this particular example, we're looking at a web page that takes in a variable called username and password. Both of these are controlled by the user. That's really important. And so then it initializes a new object of type SQL client. If you were actually making this, you would have to go pass it the username and password for your SQL database, but I skipped that here. And then you're going to do a SQL query here. We'll talk more about SQL queries in just a second, but this is a SQL query. So you take the SQL query here, and remember that the application engine is talking to a database, which is a whole nother service. So one thing that happens a lot when you are doing these backend things is the complexity of the backend with the size of your web application is going to scale, and the number of vulnerabilities, because you have more edges linking together things, is going to scale quadratically. So the more things you have going on, the more vulnerabilities, the more places things can go wrong, the more vulnerabilities you're going to have. So this one just checks and goes and finds everyone with the username and the password, and then it says if we have found a user that meets this criteria, we log them in, or we just say, no, you can't come in. So at a high level, our methodology here for doing backend attacks is going to be to go find some inputs. We want to go figure out potentially risky places to test. So like a login form or somewhere where you can go update a profile or share something with another user is going to be a lot more interesting than doing like a search query. And that's something you can kind of develop for yourself based on your intuition here. As you do more of them, you'll see some patterns in the places where things will go wrong. You want to go figure out, you want to go find unexpected output. You want to go see, if the server goes and mishandles something, and then you can just go try to exploit it. So the first thing that we'll talk about here is command injection. Command injection is all based on the fact that most of these backend libraries have commands that will just execute shell commands for you. So, you've probably heard of shell commands before, like echo, ls, netcat. A lot of different shell commands, like shutdown, reboot are also ones. You can change your password. You can do a lot of different things. Sudo. Excuse me. And in PHP, you have shell exec, which takes in a string, and it will execute whatever's in that string, basically. So the point here is that if you decide to go do something where if you decide as a programmer to go write code where you're doing echo and then user input and you can redirect it to message log if you want. This is not really necessary here. But if you go try to echo a command, it gets put right into the string here. And the important thing here is that this is not a function in PHP. This is just a string as far as PHP is concerned. So when you go and you concatenate a variable to the string, you wind up with just a string here. So this opens us up to some issues because we can put a tick in the message, and if you put a tick in a message, it just interprets it like a command. So what's going to happen if you go try to make the variable message, the tick ls tick, which is that literal there, then what's going to happen is PHP is going to say shell exec directory the output of ls, and then it's going to redirect it into message.log. So you've just put all the files that are in your current server directory into this command. So that's command injection. That's not really good. And we'll do a demo of command injection, and we'll do it right now, actually. So y'all can still see this. Okay. So I'm going to share my full screen. If there are any questions, I'm happy to take those. right now as well. So this is a little web application that I made for this, and on the left side here is the actual website that is being hosted. This was a PHP web application. It's running on MAMP, which is software that'll let you go run PHP web servers on a Mac. So as it says in the comment here, we're gonna have a little bit of, or in the home page rather, we're going to have some code that is vulnerable to some command injection. So the really important thing here is that we set the variable output to the value that is returned by shell exec ping taxi1, and then we concatenate that with post domain. And this is something that, like, after tonight, if you ever see something like this in any language, you should just immediately, like, red flags just go off. Like, you should be like, oh no, why are you doing this? Because this is really bad, and here's why. Because we could do the thing with the tick, or let's try it with a real domain first. So let's type in google.com and we'll just ping it here. And so, it runs that command. It just ran like ping taxi1, which just means only ping at one time, google.com. That resolves to an IP address, and then we see that we got 64 bytes back from this IP address. So that is what's happening here, and what we're going to do instead is we're going to do google.com. You can see where I've done this before. And then we're going to put a semicolon, which can go divide two commands in one line, and we'll just say, who am I? And then we're going to put a comment here so that anything else is commented out. That's just good practice. So now we've returned not only the output of the ping command, but we've returned also the output of who am I, our current user. You can do stuff that's a lot more dangerous with this if you're able to find one. For example, we can go cat password, and now we just get the output of my /etc/password file here. You can do that with any file on the computer that you have access to with your current user. So that's really bad. And that's something that it's hard to do right, because I'll tell you why. Because a lot of the time, it's not as like trivial as this. A lot of the time, like a couple years ago, there was, why would somebody use shell exec? Yeah, so I'm kind of answering that right now. So I'll tell you a story about it. So a couple years ago, there was this library called ImageMagick, and ImageMagick does a lot of different things for modifying images. Like you can apply a blur to an image, you can resize the image, you can do all this sorts of crap to this image. And ImageMagick had libraries for PHP, they had libraries for Node, like they have libraries for all this different stuff. But the PHP library for ImageMagick, I believe, had a vulnerability. So at the end of the day, somehow you have to go execute the ImageMagick binary to go like do this thing to it, because you can't. It's not written in PHP. It's written in C, and it's been compiled. So you have to go run a command in order to go execute it. So eventually, at some point, you're going to have to use some flavor of shell exec in order to go execute the ImageMagick library. And they had a bad implementation where they didn't filter out commands that could possibly be put in there right. And so they had a big old like vulnerability, and a lot of different websites got affected by it. So that's why somebody would use shell exec, because usually they are trying to go do something that they can't do in PHP. One, or they're just being lazy. Like if you were being lazy, you could probably go like do a ping thing in PHP. Because of this, it's generally a bad idea to execute user-given code on a server. How do coding competitions work then? So that's a good question. Sometimes they'll run them on VMs. Usually they will run them on VMs, actually, so that even if their protections don't work, they will not get like too screwed by it. But usually coding competitions will go like block out certain things that you can go do. But a lot of the time they're a bypass. I actually knew someone who found a bypass on a GradeScope, and they were able to go do this on the GradeScope autograder. So it's not perfect. But it wasn't a virtual machine, so they were able to contain the vulnerability. But they could go read other students' things. So that's command injection. And the next thing we're going to talk about is SQL injection, which is a little bit more difficult than command injection because you have to know the SQL language a little bit in order to go do it. But what I want everyone to remember here is that it's just the same thing as command injection. With SQL injection, it's going to be the same system where you're just concatenating to a string, and PHP doesn't realize that you're smuggling another command in, basically. So how many people have heard of SQL? Just before I like get into this, can I get like ones in the chat if you are like vaguely familiar with SQL, and then zeros if you've never heard of it? You don't know what a table or a column or a row is? Okay. So this is going to be SQL in 3 minutes. It's one thing about security that I've actually had kind of hard time kind of reconciling myself to figure this out is there's a certain amount of SQL syntax that you have to know to do security stuff with it, but it's a really weird subset of the SQL language. So a couple slides down here, there is going to be like a couple of useful SQL things, but like you don't have to know how to do inner joins and like all this crazy relational database stuff. There's just this really weird subset of things that you're going to have to do. So what is SQL? SQL is a way to store structured data. Everything happens in the universe of a database, and within that database, you can have a finite number of tables within it. So in this one, we're going to say that this database is my blog. And within my blog, we have a table containing users, and we have a table containing the posts that were made in the blog. The notation that we use here is we say that we have columns and we have rows. It's like, I mean, you've probably seen a table before, like on the ACT or something. So you have a couple columns, like in this users table, we have a username, password, and that created at. This is a time stamp columns, and then we have some finite number of rows within this table. Same thing is going on in the post. We have a title, a body, and we have a posted by. And then we have titles and bodies and posted by. This is called a foreign key, and it's going to mean that there's a one-to-many relationship between users and posts. One user can have a finite number of posts. They can have more than one. So that is kind of like what's going on here. And then where it gets a little more interesting is that you have SQL commands that you can run. SQL is a language. It's actually not a Turing-complete language, but it is a language for querying. So anything in SQL, some of the commands in SQL are like for updating, some of them are for deleting, some of them are for like removing tables entirely. But the ones that we're going to use a lot here for SQL injection are selecting, because we're going to be able to go hijack these commands, and we're going to be able to go get any data that we want out of this database. So what we're going to do here, like as just a demo query, to show you an example, is this is a select query, so it just returns information meeting a criteria specified with where. So we're going to select all of the columns from the users table where the username column, the value in the username column is equal to Tilson, and the value in the password column is equal to, this is a bad password. So if I were to go do this, it would return me a tuple or an array or like some data structure with just one row in it. And so that's what we're going to hijack. And then a couple like just notation things that I see trip a lot of people up with this. You have to use straight apostrophes in SQL. You can't use this like, because what'll happen is that your browser thinks that your web browser is going to think that it's smart, especially on a Mac. Macs are really bad about this. Your web browser is going to think that it's smart, and when you put in a quotation mark, it's going to be one of these guys right here. It's going to look like that. But what you really need is this. You need these like nice like straight ones here. And you might, I'm sure that there's a keyboard shortcut that'll give you that, but I usually wind up having to go copy paste them. And then the other thing is that you have to have a semicolon. That'll trip a lot of people up too. So how can we actually seen this code already. How do we do SQL? Are there any questions about SQL like before we get into the security implications of using it? Is phpMyAdmin the typical way to connect a PHP backend with a MySQL database? So so here's the thing. Like, I would say that phpMyAdmin is a really good way to look at the state of your database without using the command line. But phpMyAdmin, yeah, it's just a UI for it. Like, you would probably use like PHP SQL client, whatever they call it now. I think it probably the MySQL client. There's a native driver, so you would actually use the driver in order to go connect to the MySQL database from your PHP backend. And the driver is going to be different than phpMyAdmin. PHPMyAdmin probably uses the SQL driver in order to go connect to the database. So you can think of PHPMyAdmin as just a web application that is like a UI for your database. So SQL queries in PHP. We just kind of talked about this. So what is going on here is we have some PHP that's embedded in the HTML. Remember that all this is getting executed on the server side. We have a SQL string here, which is right here. Really, like, one thing that security will make you really good at is figuring out where quotation marks end and begin, because a lot of the time you're going to have to go use double quotation marks and single quotation marks together. There's actually a problem with this query right now, and it's that I did not use these straight apostrophes right here when I wrote this. So that was me being lazy. They're used down here, though. So sorry about that. So anyway, what's going on here is, we talked about this a little bit, but I'll go into more detail on really unpack what's happening on this line. The variable response gets set to the output of the query method on the SQL object, given this string containing a query. So when PHP passes a command to SQL, it's always passed as a string. And that string represents a command in SQL, but PHP is not going to know the difference between something. So you're going to be able to go smuggle a second query in right here. That's kind of the spoiler for what's about to happen here. So this is what it would look like on a normal day. Let's say that we send it a post request containing the value Tilson and the password containing the value, this is a bad password. So then we're going to concatenate the values of the name and the password from the previous slide into the command. And so what the query is going to look like when it gets sent off to the SQL database is select all from users where name equals Tilson and password equals this is a bad password. So that's kind of a mouthful, but that's what's happening here. So what we're going to be able to do, however, is we're going to be able to go inject something into the post parameter that lets us go do arbitrary things. So here's what is going to happen. So let's say instead of just having the word Tilson in the post, the name variable here, let's say we actually go type into an input form Tilson straight apostrophe or 1 equals 1, then a semicolon, and then these two dashes right here are a comment, which is going to comment out the rest of the PHP, kind of like in the command injection. Well, what's going to happen is the query that gets sent off to the SQL database is now going to be completely different. We're totally going to change the nature of this SQL command. Now the SQL command is going to be select all from users where name equals Tilson or 1 equals 1, full stop. And that's always going to be true, because for an OR to be true, you only need to have one of the two sides of it. So what's actually going to happen here, we're actually just going to be returning all of the rows in the users table. And so therefore, regardless of what I set my password to, response length is going to always be greater than 0, and we're always going to have been logged in. Remember that. And so this password stuff is never even going to get executed because of these two dashes right here, which are a comment. So that's the trick. That's kind of the punchline of all this. And does that make sense to everyone? Like, what is kind of happening here? Is anybody confused? I get like a 1 if you're following and a 0 if you're not following. It's nice when you're in person because like everybody like nods or they just like look at their computer. But now everybody's looking at their computer. Okay, so everybody gets it. That's great. Okay, so we'll demo this in just a second. But a couple like useful SQL tricks. Like if you're gonna like keep one slide of this presentation, this is probably the one I would keep. So 2 hyphens, and this is really important because this screws me up all the time. You have to put a space after your second hyphen, and that's going to be what comments out the rest of the line. If you don't have a space there, you're going to get a syntax error. And usually in a SQL injection problem or a SQL or a web server that you're attacking, you're probably not going to get the error back. It's just going to like tell you login failed. You also can do that for a comment. You can limit one. Sometimes it won't just be like response.length is greater than 0. Sometimes they'll say it equals 1, and therefore you can't just return all the rows. You have to go return only 1 row, so you have to go add limit 1 to your query. MD5, sometimes they'll go hash them. You have to do MD5 or some other like hashing thing. That one is a little bit tricky because you're going to have to reverse engineer how they're encrypting their passwords. Sleep 15 is interesting because it'll literally just make the SQL server like wait 15 seconds before it returns something. So if you go and you try to go put sleep 15 into one of your queries and then the page doesn't load, that means that you've probably found a SQL injection. And then when you're doing substring, there's a cool trick you can do with this so that you can go character by character and start exfiltrating data. A cool thing, there's a cool tool called SQL Map that I'll add right here that'll do a lot of this stuff for you. And sometimes it's like when you're attacking these, it's really noisy. Like if you're using SQL Map on somebody's server, they're going to know that you're using SQL Map on their server. But it's pretty effective, and it can go do a lot of this like these like obscure tricks with pretty easily. So tool for finding, exploiting, and exfiltrating SQL injection. And it's not just MySQL. There's a lot of other flavors of SQL that do the same kind of thing. You can actually go do Mongo databases as well, and like NoSQL databases. So that is all, or I'll do the demo for SQL now. So, okay, so that's that. Let's go over to the admin login page here. And first thing I'll show you, or let me go full screen again here so that I can show you the entire, so I can show you the code. Okay, so here's the admin page. This is pretty similar. I'll go through this pretty quickly because it's pretty similar to what we were talking about a second ago, but this is all in the Grey Hat GitHub, by the way, if you want to look at this code again. Okay, so we connect to the database, we get ourselves a query, and here's the dangerous thing. We're concatenating the value of the post variable with username in it, and then we're putting in the password thing as well. So we're going to query it, we're going to go look for the number of rows. If there is an error, we're going to actually print that error out, which you never should do unless you're on a development server. And then we're going to say if the count is greater than 0, welcome admin. So here's the form. Notice that the form has an attribute on the HTML element that sets it to post. That's something that you can just kind of keep in your mind. So here's the web page. We can just try admin and then some random password and nothing happens. We can go put in the right password and it'll let us right in. So now we'll do the SQL injection. I'm stupid. Okay, so now we'll do the actual SQL injection here. We can put anything in for the username, and then instead of a password, we're just going to put or 1 equals 1. Notice that there's a space at the end of that, and then we're in. Because the query was select username from users where username is admin and password is blank, or 1 equals 1 comment. So that was the query. Oops. So that is that. That's SQL. Are there any more questions on SQL? I'm gonna move on to one more thing. Cool. Okay, so what do people use? How do people exploit this kind of thing? Usually people will exploit this kind of thing using a thing called burp proxy. So burp proxy is something that will go intercept, and you can also modify HTTP requests. So I'll do a quick demo of that. Let me fire up. I did not rehearse this demo, so we're gonna see how this goes. While that's loading, here's a quick setup guide on how to set burp up. I'm not going to go through this, but it is something that it's another slide you can probably reference later because I remember having a hard time setting it up. So let's get in here. We're going to start up burp. I have the free version. I've actually used the paid version before at my old job, but we're going to use the free version today. And so what we need to do here is I actually have a second Firefox profile which has all this proxy stuff set up on it and all the SSL certificates. So, oh, you know what? I think this might not work. This isn't going to work. But I will kind of show you like generally how it works. So if I go load Google here, I'll see all the requests going in, and notice how there are a lot of requests going on because they're tracking the hell out of you on Google. You see a bunch of GET requests, you see a couple post requests. Notice how the post requests have stuff going on in the content body here. That's like kind of the thing with post requests is that most of the content goes in the body, so you can't see it in the URL. There is a little bit of information in the URL though here in this particular example. And then the other thing that you can do with burp is you can intercept things. So if I want to go load Google and I want to go like try to go inject something, I could just go and change it on the spot and forward it on. The other cool thing you can do is if you have a request that you like because you're trying to go exploit something, you can go send it to the repeater, and then you can go like edit the request all you want and send it again and again and again and again. So burp, yeah, if you're yeah, I lost my train of thought totally there. But let me share my screen again before I do that. What's the thing that you used again? Burp is the name of the software here. So one thing that I'll actually take a quick break to mention is that on Monday during our CTF meeting, we're going to be doing some back-end web problems. So there's a whole set of there's a set of like 4 problems that range from easy to hard that are all on web stuff, and I would encourage you to use Burp to go do those problems. But I also encourage you to do the problems in the first place. And on Monday at 6:30, we're going to have a recorded session where we just go over the problems. So if you haven't been to one of those, or you have like given up because of the phone problems last week, please don't do that and try these web problems out because it's really fun once you get one of these. A couple questions that I'll take. Burp or Wireshark, what is better? So there's 2 different use cases for Burp and Wireshark. Burp is really good for HTTP. Wireshark can do HTTP, but Wireshark is much better when you're like a level lower on the network traffic. If you're looking at like any like DNS traffic, some email stuff, like if you're looking at anything besides just HTTP, you should probably use Wireshark. But if you're looking at just HTTP, then you should probably use Burp. So what VPN client for Linux? I really like OpenVPN. I encourage you to use that one. So, because that one you can literally, you just type like sudo how to set up, what is ctf.io? I won't go over that here, but for the last 2 problems, I think that there is a guide on how to do that on the website. If people are having trouble setting it up, though, I can go like make a guide offline and put it in the applied channel. So you can yeah, so try to follow the guide on the website, and if you're still having problems, say something in applied about that. Okay. So I have one more demo for you here, and I don't have any slides on this one, but this one is pretty cool, and this one I've seen this one exploited before as well. So okay, so a lot of the time people will, I don't know why people do this, but I'm sure there's some reason for it. People will do this thing. Maybe you've seen, actually, can I get like a 1 if you've seen this before and a 0 if you haven't? People will do this thing where instead of going and like having you go to admin.php, they'll do like $page equals admin.php or something. And you'll probably see it next time it happens after you know what you're looking for. But for like, I don't know why they do this, but they do. And the way that this works under the hood is that they say like, we're just going to go we're going to go like get all of the contents of the file that the page variable is in the GET request here, and then we're going to go load it. So it makes it easier to go add web pages to your website, but it's really bad to do this without any testing, because what you can do is instead of just loading admin.php, which you can see right here, you could also load home.php. Or what you can do, does anyone think that they know what the trick is here? Yeah, so you can go back as many times as you want. You can just keep going up and do some directory traversal. And once again, I've loaded my Etsy password file because the value of the page variable here is now just like up /Etsy password. So we're requiring that file. So I don't know why people do that, make that mistake, but I've seen that one a lot. And it's pretty like straightforward. Actually, yeah. So the takeaway from this one that I was wisely thought of when I made this slideshow is that this is an example of something that is not just like people using a library improperly. This is just straight up people just using bad logic. A lot of backend vulnerabilities are just people using bad logic. Like they just won't check. Like, so one common mistake that people make, especially when they're doing like startups or something, is they'll say, for example, let's say let's say you're making an email client, and each email has an ID. And so let's say I have like I'm user one and I have 5 different emails, and the IDs of the emails are 1, 2, 3, 4, 5. So then user two can get in and they can just go load email 5, even though they're not user one. So they're able to go load emails for other users, and nobody checked that. And the next level of that, like on the like mind expansion meme that you have, so you can do that, or what you can do is you can go figure out the API endpoint where they're actually sending. So a lot of people will pretty easily get the one where it's like you're just loading the email of the wrong user. But a lot of the time, what you can do is you can go like reply to other people's emails, even though you can't view them. And that's really like because people think about the ones where you can just go type like email equals 5, and it'll just tell you like unauthorized, but they won't think about the post requests that actually do the interesting things, in my opinion. Um, I say that because I worked as a security intern at a company last summer, and in terms of the like high frequency and high exploitability, that's like way up here on the graph. Like it's very high exploitability and high frequency. Usually those are a high impact vulnerability. If somebody's interested in that type of vulnerability, I actually have a CTF problem that uses that kind of thing. That's pretty cool. I might put that up there just for fun. I don't know. If somebody wants me to, I will. Okay, so what are the takeaways here? Always enumerate what's going on, because if you don't know what is happening on this back end, like you're not going to be able to go do anything, really. Like you need to figure out that they're using some kind of database, and you need to try to reason about what database they're using. And you can go like straight up find information disclosure that tells you about that. Sometimes you can go run nmap and you can see that there's a filtered port on port 3306, and from that you can reason that they're using MySQL. A lot of other things like that you can do. And then the other way that you can do that is just by looking for unexpected results and looking for non-standard ways of doing things. If somebody has rolled their own way of loading a page, then you probably maybe you'll be able to go exploit it. Because people like to do things themselves and be clever, and then they don't do clever things correctly. Hey, we talked about that. Yeah, so we talked about SQL map and the other. That's actually and then this is another thing. Backslash powered scanner is a burp extension, which is created by the same people that created Burp Suite, which is Port Swigger, which James just wisely mentioned. I think I actually might get back to that in a second. But backslash powered scanner will just go try a bunch of different things. Like they'll try like apostrophes, they'll try like they'll try percent signs, they'll try like braces, they'll just try like all these different things here, and they'll try to find unexpected output. And usually, like that's a good way to go start. If you're able to find unexpected output, then you're able to go pivot off of that and go exploit it. So yeah, here's the methodology. This is kind of how I think about it. Like I go like if I'm doing pen testing, I put myself into 3 columns here. I say like, okay, where are all the user inputs? And then like which of these user inputs have interesting behavior? And then once I go figure out like, okay, so this gave me a stack trace. So I was able to go figure out what software that they're using. Like maybe I was able to figure out that they're using MySQL because of the error message that it just printed out. So once I do that, then I can go figure out that there is MySQL injection vulnerability over here. There's a squealing injection, and then you can go start exploiting that. So that's kind of the way that I think about that during like CTFs. And then back to this, there are a whole lot of backend attacks. And a lot of these come from when you're getting really complicated with your servers. Like I mentioned, the more things that you add on, the more places where things can go wrong are. And a lot of the things like happen on those edges between the two services. Like HTTP request smuggling, for example, a lot of the like at a very high level, what's going on is you have a web proxy which people use a lot to go do caching and to go make sure that not one server gets overloaded. So like on Google, they have a web proxy that will go send you to a certain server based on like what the load of each server is. And so the web proxy thinks about HTTP requests one way, and then the web server thinks about HTTP requests another way. So you're able to go like trick the proxy into go sending incorrect data, which the first proxy thinks is correct, to the second one, and then everything goes to hell, basically. So this is one that I would encourage you to go look up because I think this one's really cool. So this is web exploitation. We kind of did like 2 different lectures on web exploitation. We did front end and we did back end. And what I want to like kind of leave you with here is that there's a whole lot of other stuff that you can go to do too. We talked about like application level stuff here, but there's a whole another slew of things that you can go exploit, from like even just the wiring to the IP addresses to the Wi-Fi network to like SSL to all this different stuff. Injection was really important here, and so like injection is really the big like takeaway for any kind of security stuff, whether it's binary exploitation or it's web exploitation. Injection is probably what is going to be what helps you here. Hey, look at that, James. Portswigger Web Security Academy is a really good place for going and learning about these kind of attacks. They have a bunch of different labs on there, which like get harder as you progress, but they show you cool tricks. And the nice thing about Portswigger is that they actually make Burp Suite, so they know what kind of things actually get exploited. The other really cool one that I like a lot is the HackerOne Hacktivity. This will just like tell you a list of things that have been exploited on websites with bug bounties. So like you can go down here, you can go see that somebody found remote code execution. That was actually what kind of like the vulnerability that we were talking about earlier. And it tells you exactly how they found this remote code execution on Slack. And like it shows you how they used Burp to do it. So you can go like read this, and if you really understand it, it'll probably help you go stay up to date with like all the tricks that people are using. So that is that. This has a license on it. And that's all I've got for you. Are there any questions?